Hi my dear friends, welcome back to our YouTube channel. This is your ADC. Welcome to our YouTube channel ADC Maths. ADC Maths. Okay. In this class, in this series of video lectures, this is the another one, matrix and its types. So what is my matrix? Matrix is an arrangement of numbers, elements. How they can be arranged? They can arrange horizontally, they can arrange vertically. Have you go to the movie theater, in the cinema, the screen, you find some seat number. So how we can find out the seat number? A, B, C, D, E, F, A20, A21, BC, there is a C20, D12, D13. So there is an arrangement so that we can know the capacity of the screen, isn't it? So how many seats are there? How many seats are filled up? How many tickets are sold out? How many are still there vacant? So based upon that, you can find out the place and you can choose your seats as well as when you are going to book through online. Now matrix is the same category, is an arrangement. So we can arrange the setup, we can make the setup, the arrangements of the given elements into the horizontally and vertically. And generally, a matrix capital A is an element Aij. I stands for the number of rows, J stands for number of columns. So I varies from 1 to M and J varies from 1 to N. That means the horizontal. Horizontals are called the rows. So first row, second row, third row, fourth row, continue that mth row. So the first two the elements is 1 1, 1 2, 1 3, 1 4, etc. 1 n up to n. What is this n? This is a vertical line. So first line vertical line, second line vertical line, third one, etc. etc. nth one. So this vertical line is called the column. First column, second column, third column, etc. etc. nth column. So there are m horizontal lines, n vertical lines. So the m is called the row, n is called the column. So a matrix is represented by their order. The order is nothing but the number of rows into number of columns. So m stands for number of rows and n stands for the number of columns. Right? What about m and n? The numbers only, isn't it? Suppose m and n are same, then number of rows and number of columns both are same. What's the mean that? We get the square matrix because 2 rows, 2 columns. So we get equal. 2 rows, 2 columns, isn't it? So for example, A, B, C, D. How many rows are there? 1, 2. 2 rows. How many columns? 1, 2, 2. So the number of rows and number of columns are same. It is called the square matrix. Suppose the number of rows is not equal to number of columns, then obviously it is not a square. It may be a rectangle. For example, A, B, E, F. So how many rows are there? 1, 2. 2 rows. How many columns? 3 columns. So the number of rows is 2, but number of columns is 3. So this is the example for the rectangular matrix. Right? Now, what other types of matrices? Column matrix. Column means only one column. Only one column, many number of rows. M number of rows. So A, B, C, D, etc. etc. But only one column vertically. What about the row? Row means horizontal. What's my row matrix? Only one row. A matrix contains only one row but many number of columns. So see that A, B, C, D, etc. etc. Only one row only but many columns are there. So this is called the row matrix. Only one. So first place for the row only one into any number of columns. N number of columns. Column matrix, any number of rows but only one column. So it is called the column matrix. Other than that, what is in the unit matrix or identity matrix? Unit means number 1. So the value 1 is only on the diagonal. So this is the identity matrix of order n, 1 0 0 0 etc. 0 1 0 etc. So what will be the I2? So this is called the I2. I2 means 2. So 1 0 0 1. What about I3? I3 means it is 1 0 0 0 1 0 0 0. There are 3 rows, 3 columns. This is only for the square matrix. This is also known as identity matrix. Right, sir? Because it is identically equal to 1. 1 is called unity 1. Unity means 1. So unit matrix. What is the diagonal matrix? Yes, of course. The diagonal elements are alone non-zero, others are 0. The diagonal elements are alone 0, the others are 0. It is called the diagonal matrix. Any order can extend for any order. What about scalar matrix? Each element in the given matrix, it is a multiples of some scalar. For example, see that 5, 10, 15, 20. It's a multiples of 5, isn't it? Right? Then take 5 outside. So 1, 2, 3, 4. So now here k is called scalar. So it is the example for the scalar matrix. For example, let us consider the second one, 5, 0, 0, 5. When take my 5 is outside, because 5 is the scalar here. 5 taken outside, 1, 0, 0, 1. Sorry, each element is a multiples of 5. Each element is a multiples of 5. Then it's possible. That's right. So 5 into 1, 0, 0, 1. So this is also a scalar matrix. Is in terms of the identity matrix. So this is the I2 example, isn't it? So 5 times I2. So any scalar matrix can be written, if possible, into the identity matrix. Otherwise, we can write like this. The other two important types of the matrices are triangular matrices. We get a triangle shape. We will get the triangular shape above the diagonal, below the diagonal. That's the concept. So let's see the first example. A, B, C, 0, D, 0, 0, 0, E. See that? I put 0 here, no problem. But above this diagonal, above this diagonals are non-zero, right? Above this diagonals are non-zero. Some elements are 0, no problem. But most of the elements are non-zero. So we get a triangle. We can form a triangle above this diagonal. This is called the upper triangular matrix. See this next example. This is a diagonal element ACF. Let us see that below the diagonal element, all the elements are non-zero. So this triangle looks like the lower triangle. So this matrix is called the lower triangle matrices. Right? So there are two types of triangle matrices. The above the leading diagonal elements, we form a triangle is called upper triangle matrix. When we form the triangle below the diagonal, we get the lower triangle matrix. You see that below this side, everything is 0. Above that, we get everything is 0. So that is the concept. Above and below. If any one side is non-zero, one side is 0, then those matrices are called upper and lower triangle matrices. These matrices can be found or framed with the help of some elementary row operations for the upper triangle matrices and column operation for the lower triangle matrices. Got it? Upper triangle matrices can be obtained by using row operations. Lower triangle matrix can be obtained by using the column operations. Let us discuss in a separate video for the column operations and the row operations. Now, when we say that the matrix is symmetric, it's called symmetric. You see the mirror reflection. That means that the matrix and its transpose are same. The matrix and its transpose. What's mean transpose? What's the transpose of a matrix? Changing the rows into the columns. Changing the rows into the columns. For example, you see that suppose my A is equal to 1, 5, minus 2, 5, 4, minus 3. I'm saying just an example. 2, 1, 3. This is my matrix A. So this is my row. This is the second row, the third row. What will the A transpose? Can I convert the first row into the first column? Second row into the second column. Third row into the third column. Now both A and A transpose are same? No. So this is not a symmetric matrix. This is the non-symmetric matrix. But what I am saying that how to write the transpose? The transpose of the matrix is nothing but writing the row as a column. Writing the row as a column. Writing the row as a column. This is known as the transpose of the matrix. Suppose the transpose of the matrix and the given matrix are same, that is called symmetric matrix. See the example 1 minus 4 minus 4 2. Can I write minus 1 comma minus 4 as first column? Yeah, the same thing. And minus 4 comma 2 the second column, the same thing. Otherwise, you can easily identify the symmetric matrices. Just put the diagonal line. Now, this diagonal is look like a mirror. So, I have seen that it will be reflect the same what we have in the above the diagonal, the same in the below the diagonal. This is called the symmetric matrices. This is called the symmetric matrix. I'll give you one more example for the symmetric matrix. You see that A is equal to 1, 2, 3, 0, minus 4. So it is 0 here, minus 4 here, and 5. You see that? So this is the A. Clear? This is symmetric matrix. How? You see that? This is my diagonal. It's clear? Now see the reflection. See the mirror reflection. Here 0, here 0, minus 4, 5, 5. So the same thing, isn't it? So same thing. Now can you write the A transpose? You get the same answer. The first row 1, 0, 4, minus 4. Yes. Second row 0, 2, 5, 0, 2, 5. Third row minus 4, 5, 3, minus 4, 5, 3. Again, once again see that 1, 0, minus 4, 0, 2, 5, minus 4, 5, 3. So A and A transpose are same because it is symmetric. Right, sir? So this is symmetricity means above the diagonal and below the diagonals are the same elements. That means that in other example, the A transpose and the A are same means Aij is equal to Aji. What is Aij? So what is this element? A11, A12, A13. This is the element A21, A22, A23. This is the element A31, A32, A33. Now see that A11, A22, A33 is a diagonal, leave it. What about A12? So I equal to 1, J equal to 2. What's the reverse? 2, 1. So yes, A21. What about A13? What is the reflex symmetricity? 3, 1. So A31. So both are same. What about A23? Is nothing but A32. So that is the concept of the symmetric matrix. And finally, determinant of a square matrix. Yeah, can you consider the same example? What we'll get? What is the symmetric matrix? There is a determinant of a square matrix. 1, 0, minus 4, 5, 2, 3, 6, 1, 0. So I am considering some matrix. It is not a symmetric matrix, some matrix. How to determine the determinant of this matrix? I go for the first 2 by 2 matrix. Cos theta minus sin theta, cos theta. So this is the given matrix now. What is the determinant of this matrix? Tell me. Determinant means I use the straight lines. I use the 2 straight lines. So multiply the diagonal elements. Cos theta into cos theta. It is cos square theta minus the opposite diagonals. Sin theta into minus sin theta. It is minus of minus plus sin square theta. So cos square theta plus sin square theta is 1. That's it. This is for the 2 by 2 matrix. For 3 by 3 matrix, let us see this example. 1, 0, minus 4, 5, 2, 3, 6, 1, 0. I am going to expand this with the help of the first row. With the help of the first row. So we start the plus, minus, plus. Plus, minus, plus. So the first one, 1, if you want to consider this element, first element, remove or omit or neglect the first row and the first column. What's the balance? The balance is 2, 3, 1, 0. Once I repeat this, if we omit the corresponding, we neglect the corresponding rows and the columns, the remaining is 2 by 2 matrix. Because a 3 by 3 means the immediate cofactor is 2 by 2 matrix. The minor matrix is 2 by 2 matrix. Right? Then minus sign was there, 0. Yeah, it's minus 0. Again the same row and this time the middle column is eliminated. The balance is 5, 3, 6, 0. 5, 3, 6, 0. But unfortunately this is 0. So 0 and anything is 0. So let us leave. The last one is plus. But this element is minus. So this is minus 4 of the same thing. Eliminate the first row and the third column. If you eliminate the third column, what's the balance? 5, 2, 6, 1. So 5, 2, 6, 1. Let us find this value. We get the determinant of the matrix. So is equal to 1 into 2 into 0, 0, minus 1 into 3, minus 3. What about this term? Whatever, so this is 0. 0 into anything 0. So let us leave this term 0. Right? The last one is minus 4. 5 into 1 is 5. Minus 6 into 12 is minus 12. So what will you get? Determinant of A is equal to 1 into minus 3 is minus 3. How much this? 5 minus 12? Minus 7. Minus 7 into minus 4, it is plus 28. So the answer is 25. So determinant of a matrix is nothing but a constant which is corresponding to the whole matrix. Whole matrix is a constant which is corresponding to the given matrix is known as the determinant. Thank you for watching our YouTube channel ADC Max. Thank you.